The periodic table of elements is a chart often referred to in chemistry because of the information it provides. It is organized by the trends that occur among its elements. In this video, I'll be going over these trends. The 7 horizontal rows of elements are called periods, and the 18 vertical columns are called either groups or families. Elements in periods are in increasing size and atomic number order, and elements in each group are physically and chemically similar. The first group consists of the alkali metals, but does not include hydrogen. Alkali metals are highly reactive due to having only one valence electron, that is, one electron in its outermost shell. Group 2 is made up of the alkaline earth metals, which are less reactive than the alkali metals, but form bonds easily. The elements in Group 2 all have 2 valence electrons. Groups 3 through 12 are transition metals, which have special electron shell arrangements that allow them to bond to many other elements in different shapes. Groups 13 through 16 are main group elements, which are mostly nonmetals with some metalloids mixed in there. Group 17 is the halogen group. Elements in this group are very reactive because their valence electron shells are nearly full. Halides are the name given to the compounds of a halogen and other elements. Halogens usually bond with metals to form salts. Inert gases, or noble gases, are the final group, which have full outer shells and are therefore unreactive. The number of valence electrons in groups 13 through 18 is equal to the difference of the group number and 10. The 2 seemingly additional periods at the bottom are actually part of the 6th and 7th periods, and are the lanthanide series and the actinide series respectively. The entirety of the table can also be sorted into 3 categories: metals, nonmetals, and metalloids. In chemistry, metals are elements that conduct heat and electricity well, lose electrons to form positive ions, and are very pliable. Nonmetals are elements that conduct heat and energy poorly, gain electrons to form negative ions, and are very brittle. Metalloids share the characteristics of both metals and nonmetals. The atomic radius is just what you'd expect it to be, the distance between the nucleus and the valence electron shell. As you move down a group, atomic radius increases because more electron shells are added. As you move down a period, atomic radius decreases because opposing charges get stronger with every pair of subatomic particles. Electronegativity is the measure of an atom's ability to attract electrons from another atom in a compound. An atom's electronegativity is listed on the periodic table according to the Pauling scale. Fluorine has the highest electronegativity of all the elements because it's close to completing its valence electron shell, and it has a small radius, which means it experiences less shielding. Shielding is the concept of forces weakening over distance. The greater the atomic radius, the further away the valence electrons are, and the less of the attraction to the nucleus they have. Closer electrons sort of stifle out the charge, so the valence electrons are bound by a weak force. A similar concept is shown in magnetism, where you'll find that the further away from a magnet you are, the weaker the force. Because noble gases are stable with full valence electron shells, they don't have any electronegativity. Ionization energy is a measure of the energy required to remove an electron from an atom, which, let me remind you, is neutral. Of course, the name comes from the fact that adding or removing an electron from an atom makes it an ion. Ionization energy decreases down a group because less energy is required to remove an electron from an atom with more shielding. Ionization energy increases down a period because as each electron is added, a valence shell becomes more full. A fuller shell is less prone to giving up electrons because an atom always seeks the easiest way to have a completed shell. That's why fluorine, being 1 electron away from the full shell, has the highest electronegativity. It is easier to gain 1 electron than to give up all 7 of its valence electrons. On the other hand, francium has a low ionization energy because it experiences a great amount of shielding and only has to give 1 electron in order to have a complete shell. So to recap, we learned that the periodic table is an index of elements that is organized into periods and groups of similar properties. As we move down a group or period, we find that properties such as atomic radius, electronegativity, and ionization energy change. Next video will be about quantum numbers and electron configuration, and you can find a link to more of my chemistry videos in the description.